Okay, so some of the most asked questions in the last lesson, for example, if we had a formula 2n, people were asking me, do you always have to start with n is equal to 1, then you go to 2, then you go to 3, and so on and so forth? And then I said, for now, yes, because we want to write the sequence from its first term. And its first term always exists when your n is equal to 1. That's why we start from 1. But it's not a must that whenever you look at a sequence, you should like directly start from 1. For example, if we are to use this formula to write down a sequence, our formula is 2n. What would our sequence be? Can someone tell me what our sequence would be if our formula was 2n?
It should be 2, 4, 6, 8.
Let me add some. Let me see, 12, 14, and so on and so forth. Now, sometimes they'll bring a similar sequence, but then they eliminate maybe the first 3. And then they give you a sequence starting with 8, followed by 10, 12, 14, and so on and so forth. And they want you maybe to find the next 2 numbers. To find these next 2 numbers, you'll still use this same formula. Or you will just keep adding 2, which is the same as using the formula. For example, here our n would have been, what is the n for the value of 8?
8. That one was 4.
It is 4. And this one?
5.
5, 6, 7. So to get the next one, it would be 2 times 8. Then the other
16.
one, it would be 2 times 9. So you realize that the formula keeps on working even if you do not start with the first term, n is equal to 1. It keeps on working. So for us, we are just starting from 1 because we want to write the sequence from its first term. But later on, when it will become wherever you use sequences, we shall see where you use sequences. Starting today, we shall be seeing where you use them. So when you get there, when you become auditors or programmers, or you start doing some coding, you will be the one to decide where to start from, which term to start from, because this is definitely not the first term, it is the first term. So you can decide, let me start from my 10th term. Let me start from my 100th term. But the formula, when you're generating the sequence, you start from the first term. For us, when we are generating them. So that was like one of the most asked questions. I don't know if people had understood it the other lesson, but if they had not, I hope now they've got it. It's not a must. There is a lot of freedom. You can do whatever you want later on when you're applying this mathematics. For us, we are just doing it because we want to start with the first term. It's easier. It's easy to get the formula, to use and get the formula when you're using the first term. Okay. Okay, so today we are going to start with some exercises to check whether people really understood the last lesson, and also to check if people can answer the questions in case they are brought up again or in case they need to apply them. So for those that want to follow directly, I'm using the prototype book and it's page 82. Page 82, in case you want to follow, but if you don't want to bother yourself, it's okay. I'm going to be putting everything down here. Okay, so basically here we have that this diagram thing, it is a flow chart or a flow diagram. Okay, I don't know who has muted, so let me just mute all of you so that we avoid that funny noise in the background. Okay, so this is something like a flow chart, though it is a very short one. It starts here and it ends here. So basically it's like 2 steps. So they want you to fill in this question mark. This is a question mark. I don't know if people had noticed it's a question mark. They want you to, of course, this one corresponds to the 11, the 2 corresponds to 12, the 3 corresponds to 13, the 4 corresponds to 15, and so on and so forth. So they want you to find out how they were coming from these numbers above to these ones. So basically that's what they mean by this question mark, like what were they doing to come from up here to down there. Okay, you can think about it. You can think about it and you tell me. Hopefully today I see some new hands. Okay, Marilyn is saying I've missed 14. According to the book, the 14 is not there. So let's first try maybe to get the formula. We see whether it's an error in the book or whether the sequence is actually okay. Let's first think about it and see. So whenever you're ready, you put up your hand or you text me in the chat room. So basically these are the terms. Your first term is 11, your second term is 12. So they want you to figure out what they were doing here. What they were doing to that n. What were they doing to the n to get those values there? Yes, Maysoon.
Good morning, teacher.
Good morning.
They got n plus 10. Though according to the method, I failed to get because since there is no 14, according to the book, there is no 14. According to the method, I failed to get the 15, but then I got 11, 12, and 13.
Okay. Okay, let's see if that works. For our first term, which is 1, it will be 1 plus 10. And that's
782.
So this is okay. Someone, please mute your microphone if you're not giving an answer. So that I don't have to come and mute you. So for the first term, it's okay. For the second term, it's also okay. For the third, it will be 3 plus 10. It's also okay, 13. Then for the fourth, it does not apply because when you add 4 to 10, you have 14. So maybe there is a possibility they missed out the 14. Let me hear if anyone else has another method. The blackboard is a bit blurry at the bottom. I don't know why. Let me try closing that. Hasn't helped in any way. I hope you can see clearly though. Okay, do we have any other contribution? Yes, we are still looking at sequences. Louise doesn't understand what we are doing. Okay, we have about 5 more, so maybe as we go on, we shall be able to. Okay. So, wait, we shall say plus 10. To show that 1 plus 10 is 11. 2 plus 10 is 12. 3 plus 10 is 13. 4 plus 10 is 14. Then 5 plus 10 is 15. So if you have the hard copy book, you can fix the 14. If you don't, just keep it at the back of your mind that they had skipped the 14. So in this case, our formula is n plus 10. For those that missed last time's lesson, or those that are not yet following, this n stands for these values here. So for the first value down here, the n is 1. For the second value down here, the n is 2. For the third value down here, and so forth.
No, stop it.
Okay, Bambi, some people didn't attend the lesson last week. Okay, I'm going to try and take my time on the examples. Okay, I'm going to put another one. It's also similar to this. They are about 4 diagrams. So still we have 1, 2, 3, 4, 5. But those that missed last time's lesson, you really missed a lot. I hope we managed to catch up in this time. So here we have 10, 20, 30, 40, 50, and so on and so forth. Okay, last time we were discussing how these people come up with these sequences, first of all. Because remember, when they give you a sequence, you don't know how it comes about. You're supposed to just study it, use trial and error, and try to figure out how they came up with a pattern, and then you can either guess the next number or the next 2 numbers or whichever numbers they've asked you for. So we were trying to see how those people come up with sequences. Because that is actually what we want you to be able to do. We want you to be able to look at a real life situation and come up with a sequence of your own. So we say that when you're creating a sequence, you use terms. These are terms. The terms are really infinite when it comes to sequences, because once you get a formula, you can go on. Here they stopped at 5, but you can go up to 1 million, you can go to 1 billion, you can go up to 10 if you want. So it's up to you which term you stop at. But the first term your n is 1, the second term your n is 2, the third term your n is 3, the 10th term your n is 10, the 100th term your n is 100, the 20th term your n is 20. So here we are trying to see, these are terms. So we want to see how do you come from here to here? What were you doing to this n to get these things here? What were you doing to the 1 to get 10, the 2 to get 20, the 3 to get 30? I hope people who had missed are somehow getting an idea. Yes, Miracle?
N times 10.
N times 10. Okay, thank you. So I'm going to just put in here times 10 to show that I multiply the 1 by 10 to get 10, the 2 by 10 to get 20. Okay, this one was a bit, it was a bit very, very direct. Okay, should we do another one?
Yes, teacher.
Yes, teacher.
Yes, teacher.
Louise, that were not there. So still here they are starting with the first term. I think I explained why we keep starting with this first one, because we want to see the sequence from its first term. But later on, when you are pros, you can start from each term. Actually, even by the end of the day, we may be starting from whichever term you want. This one is very interesting. So, how are these people coming to this one? I'm going to remove this. So they want you to figure out how people are coming from here to here. It seems Louise has finally caught up. Then I'm also seeing in the chat room. Louise, can you take me through?
Teacher, the working is 1 times 7, 7. You multiply 7.
So you multiply.
You get 1 times 7. Yes.
Okay. Okay, thank you. That is, I think that is true, right? The first term, 1 times 7, you got 7. The second term,
Yes,
2
teacher,
times
it's true.
it is true. But now we are going to put here times 7. But now when they ask you for the general formula, the general one, the general formula, you say n times 7, which can even be written as 7n. So this is what we actually looked at last time. They would give you the formula and then you have to generate this sequence. Now this time they've given you the terms and the sequence and they want you to generate the formula. You are getting the closing. The other time they will give you the formula and then you just fill in. For 1 it is 7, for 2 it is 14, for 3 it is 21. Now this time they've given you this and then you're supposed to find the formula. And by the way, most times this is what you will do. Most times you will have a sequence and you want to find the formula. But sometimes you have to get a formula to get what you want and then you just fill in and get a sequence. Okay, let me put one more. Someone has also just joined. I think I should stop beginning right on time. Because some people join a bit later. Maybe we should be giving them a grace of like 5 minutes. So that they don't feel so left out when they join. Okay, now this time, here we have 2.5. I'm saying it out just in case it's not clear. This is 2.5, 3.5, 4.5, 5.5, and 6.5. So they want you to figure out how they came from here to there. Okay. Yes, Isabella.
Teacher, the answer you get on adding that together decimals, you have 0.5.
You add the 0.5.
Yes, to 2.
Okay. So let me put this down. Let's check. We need to work 1 plus 0.5
is 1.5.
And our first term is 2.5. Isabella, do you want to adjust your answer? Okay.
It's 1.5. Sorry, it's 1.5.
I wanted you to be the one to see it and tell me. Okay, so they were adding 1.5. So in this case, what would the general formula be? What would the general formula be? Thank you, Paula, and the people that are giving answers in the chat room. I see them, Hannah. Okay. What would the general formula be? Let me see, who should I choose? Okay, now Mason says the general formula should be 1.5 n. What about you, Marilyn? What do you think?
I say it should be n plus 1.5.
Yes, it should be
What I said.
plus 1.5.
1.5.
Adding. If
Yes.
we
Sorry, it was an error. It was an error. I accidentally got the plus.
Yeah, I had gotten worried. I was going to say, okay. Then there were also some other people that were giving me 1.5 n. I hope it was just an error, but if it wasn't, when you're adding, it will just be n plus 1.5. When you're multiplying, then that's when you can say that this is 7n. Okay, by the way, you guys can ask questions at any point, at any time, till you can ask a question. Can I remove this? I guess I can. So that work was on page 82. You can bring it in form of that, or they can just bring the sequence and then you have to figure it out. That is one way of stating it. The other way is by just bringing it. Yes, Ruth, you have a question?
Teacher, what if they ask you to find the sequence using a certain formula?
What if they ask you to?
Find a certain sequence using, find a sequence using a certain formula. Like,
Oh, that is what we looked at last time. Before we look at the second exercise, we can briefly look at it. They can tell you to find a sequence that corresponds to maybe a formula like 3n plus 1. That's what you're asking. They give you the formula itself and they want you to find the sequence. Who wants to help me explain to Ruth?
Pardon?
Someone wants to help me explain to Ruth how you can use a formula to generate a sequence. I want other people to also participate. People like who? Let me see. People have beautiful names, but they can't even put up their hands so that I mentioned their beautiful names. People like who? Skylar, you even from this planet? I don't know. Don't leave the class to only a few people. I want someone new, someone who hasn't said anything. People like Chemtai, Rita, Gabriela, Hannah. Okay, Hannah, I think Hannah has been participating in the chat. Yeah. Because if you are not participating, it means you are not understanding. Okay, Regina. Unmute yourself before you speak, otherwise we can't hear you.
We are going to generate the formula where we multiply 3 times 1 plus 1, which is 4. Then we say 3 times 2 plus 1.
Which is?
7. 10.
Go on.
What is it?
3 times 3 plus 1, which is 10.
Okay, thank you, Regina.
3 times 4 plus 1, which is 12.
3 times 4 plus 1. 3 times 4 plus 1 is 13. Because 3 times 4 is
13, yes.
Okay. So basically, who had asked? I've forgotten. I think it was Ruth, Karunji Ruth. Basically, we use these terms the same way you've been seeing them above the chart. 1, 2, 3, 4, 5, and so on and so forth. You don't already stop on 5. You can go up to 10 if you want. We just stop at 5 because I don't know. Even last time we were using 5, but you can go up to wherever you want as long as you put a dash to show that the sequence goes on. So these numbers don't have any special meaning.
teacher.
This one just means that you're generating the first term, 1. 2 just means that you're generating the second term. 3 just means that you're generating the third term. Just that now when you're filling in the formula, for the first term, where there is n, you put 1. For the second term, where there is n, you put 2. For the third term, where there is n, you put 3. That's why Regina was saying, for my first term, it is 3 times 1 plus 4. She has put the n, she has put 1 where there is n. 3 times 1 plus 1, which is 4. sorry, the 4 is here. Then for the second, it is 3 times 2 plus 1, which is 7, and so on and so forth. Where she has stopped on the fourth term. So you already put a dash to show that your sequence goes on, because someone else will stop on the 9th term, someone else will stop on the 5th term, but the sequence goes on. I hope you've understood, Ruth.
Yes.
Bambi, you can ask questions at any point. Like you just ask, I'll answer. It will even help these people that have already understood. It will help them understand better. So you just ask whenever you can. Okay. So here, so the other part, when they give you the formula, that's all you do. You just fill in for 1 to get the first term, for 2 to get the second term. But sometimes they ask you can call it the converse, the reverse, the opposite. Yeah, they can ask the other way around. They give you the sequence and they want you to find the formula. So our first sequence here is 5, 9, 13, 17, 21. So they don't want you to like really find the next number. They want you to find the formula this person was using to generate this sequence. They want you to find the formula this person was using to generate this sequence. Your first term is 5, your second is 9, followed by 13. So this takes some bit of time. I'll give you some time to think about it, and then you give me the answer. Or if you find, no, but let me first give you a chance. I would have done the first one and then maybe you do the others, but since we've looked at many of such, let me first give you an okay, Marilyn already has something to say. Okay, Marilyn,
So
you
the
keep
formula. So should I say the answer now or I should wait?
No, you keep your hand up and you wait. I get more
Okay.
hands. Give me your answers at once. Jemima, I saw your hand up. You keep it up. Someone is using a Huawei MatePad. Please rename and put your name so that I don't call you Huawei. Then Hannah, you people are sharp. I thought I would have to do the first example for you, but I see people are, okay, that is nice. Okay, those are enough hands. Let me hear your answers in the order of the hands. Marilyn, what's your formula?
N plus 4.
N plus 4. Thank you. We shall check the formulas later. Kaihura Hassan. Sorry, Hannah. Hannah, what's your formula?
My formula is 4n plus 1.
4n plus 1. 4n plus 1. What about Zoe? 4n plus 1.
Mine is the same as for Marilyn. Mine is n plus 4.
Okay, thank you. I see even Henry has n plus 4. Karudi has n plus 4. Miracle has n plus 4. Okay, thank you. Does anyone else have a different formula?
I'm wrong. Oh my God.
Okay, let's check. By the way, having a different answer does not mean you're wrong. What you people even should, I can't wait for you to come to like the real world of mathematics and you see like how interesting it is. Like there are so many ways to come to the same things, so many ways. There could even be like 5 formulas to this. Yes, Regina? Come in, you're late.
Mine is 4n plus 1.
4n plus 1. So your answer is the same as Hannah's answer. Okay, Venalia. Okay, it's okay. But we are already studying, Jeremiah. I think we're even about to finish. But you'll attend maybe the next lesson. Okay. Okay, so I think those are the only two formulas we have. Let's check them. Let's first check this first one, n plus 4. Our first n is 1. 1 plus 4 is 5. So it's check for the first term. Our second term is 2. 2 plus 4 is 6, right?
Yes.
Yes. So it does not check for the second term. Let's say maybe it checks for the third term. Though, of course, if it doesn't check for one of the terms, then we cannot adopt it. For the third term, it would be 3 plus 4, which is 7. So it's not checking for what? For the other. It's only checking for one. Okay. Okay. In the chat room, Henry says both methods are correct, and I think I understand why he's saying that. Let me emphasize this: when you're finding the formula of the sequence, you do not use the sequence itself. You use the terms. Your n is equal to 1, 2, 3, 4, and so on and so forth. Do not use this, because when you use this, that's how you end up with a formula like n plus 4. Because when you use your first term as, your first n as 5 instead of 1, if your first n is 5, when you add 4, you will get 9. When you add 4 to 9, you will get 13. That's how you ended up having that formula of n plus 1. But you're supposed to use this. Your n is supposed to be equal to those ones. Yes. You've been in class. Hey, have you guys got it? You use these ones here.
Yes, teacher.
Yes, use these ones here. So let's check for this. 4 times 1 plus 1.
5.
4 times 2 plus 1.
9.
9. Okay, so it works for the first and second term. Then 4 times 3 plus 1.
13.
13. Does it work for all the terms?
Yes.
Yes. Okay, so for number 1, for this you can write down. For number 1, our formula is 4n plus 1. Kathy, we are learning sequences. We are learning how to generate the formula from the sequence. Your name sounds new. I think maybe you've just joined the whole program. I'm not very sure. Okay, so this is another sequence. I think by like the fourth one, people will be knowing the right answer throughout. So this is the other one. We don't want the next number. I just want the formula. Do you have somewhere to write? You people were ahead. But if you're learning about drawing, it means you learned this. You did? You skipped it. Okay. I hope you try to follow and get something. Okay, sorry about checking the screen, but what formula do you think they were using for this? Okay, they soon has her hand up. Let's wait for more people to put up their hands. You see what happens is when one person gives an answer and then it's not the same as your answer, then for you, you keep quiet. That's why I want to put up their hands and I hear different answers. Okay, Mason, you keep your hand up. Okay, I also have Alicia. I need like, okay, I think those are enough. Alicia, what's your formula?
Good morning, teacher.
Good morning.
My formula is 3n minus 1.
3n minus 1. Even Rania's formula is 3n minus 1. Maysoon, what is your formula?
Teacher, I also got 3n minus 1.
3n minus 1. Does anyone else have 3n minus 1? Even if you have the same, you tell me so that, okay, Marilyn has 3n minus 1, Miracle has 3n minus 1, Hannah has 3n minus 1. Okay. No one has a different one. Okay, even Melissa has 3n minus 1. Let's check 3n minus 1. So remember our first term is always 1. Our first n is always 1. Then you go to 2, then you go to 3. Let me count 1, 2, 3, 4, 5. So these people were stopping on the 5th term, and then they do the dot. So when your n is 1, you have 3 times 1. 3 times 1, which is 3. Minus 2, sorry, minus 1 is 2. Okay, it works for the first term. 3 times 2 is 6, minus 1 is 5. It works for the second term. 3 times 3 is 9, minus 1.
9 minus 1, 8.
Then 3 times 4. 3 times 4, we have 12. Minus 1, you have 11.
Minus 1 is 11.
Then 3 times 5.
15 minus 1 gives you 14.
Okay, so our formula is 3n minus 1. You see, people are getting it by like the first one. People will all be giving me the what? The right answer. Okay, Angela is requesting us to slow down a bit. Okay, so Jemima asks, can n plus 3 work? Let's see. If you use n plus 3, your first term is 1. 1 plus 3 is 4. And our first term is 2. So it cannot work. You don't use this sequence itself, you use the other one. First term, you use n is equal to 1. For the second term, you use n is equal to 2, like that. I hope I've answered your question, Jemima. Okay, so Angela, you can ask a question at any time, but yes, we are going to slow down a bit. But if you ask a question, it will be very easy for me to help you understand. So I think for this number here, for those that have finished, you can put up your hand. But for the sake of people like Kita and Angela, I think I'm going to do it. So basically, we've been looking at sequences and patterns. You guys looked at sequences in primary, whereby they just give you a sequence and they tell you to write the next number. Sometimes you're adding, sometimes you're multiplying, sometimes you're subtracting, sometimes you're dividing. Though division is very rare, it's very rare, but it's a possibility. So now we are trying to think, because we are preparing for the future, we want to see how these sequences are used. When you get a sequence from normal time, for example, you get a sequence from weather, we say we use sequences to do things like predictions, like weather forecast. So let's say maybe you get your sequence from, let's say 5 years, you say, in 2000, it rained in January. January is the first month. Then it's okay, it rained maybe in January and Feb, then around March, it rained maybe like up to June, like that. Then the next year, you're like, did it rain again in January? Then the next year, then the next year. Then from there, you generate a sequence. Then after generating that sequence, you're supposed to generate a formula so that you predict what may happen in 10 years. Will it rain in January in 10 years? That's how those people are able to do predictions, to say maybe within this time, there will be global warming. Like things like global warming were predicted. These things that are happening, they were predicted already, and they told people to plant trees. But you see, people don't believe till things happen. So you're supposed to be able to get the formula from the sequence. They've been giving you sequences, but you do not know where those sequences are coming from. For example, they give you like such a sequence and they tell you, write the next two numbers or write the next number. That one I know people can do. But what we are doing is we are trying to figure out what the formula is. Like, how did the person get 6? How did the person go to 11? Why did they go to 11? Why did they go to 10? How did the person go to 16? You know, like what are they following? And then I was saying, these people use things like terms. The first number in your sequence is what we call the first term. And for your first term, your n is always equal to 1. Let me put n here somewhere. For the second term in the sequence, your n is always equal to 2. For the third term, your n is always equal to 3. For the fourth term, your n is always equal to 4, like that. So you ask yourself, what to get the formula? You ask yourself, what did they do to 1 to get 6? What did they do to 1 to get 6? So someone may say they added 5 to 1. Someone may say they added 5 to 1. So when you add 5 to 1, yes, you get 6. So maybe you can say, maybe my formula is n plus 1. So you check, will it apply to my second term? When I add here, we add when you add 1 to 1, sorry, it's not 1, it's 5. When I add 1 to 5, you get 6. So when you add 2 to 5, do you get 11? Do you get 11? No. So if you realize you don't get 11, then you throw away that formula and you keep modifying and modifying. You can try maybe, you can try n times 2. It will be 2n, and maybe plus 4. So that would be like 2n plus 4. You ask yourself, can it work? Can it work for all? When you put n is equal to 1, you have 2 times 1 plus 4, which is 2 plus 4, which is 6. So you see, it works for the first term. Then you ask yourself, does it work for the second term also? The second term, your n will be 2. The second term, your n will be 2. So you have 2 times 2 plus 4. So you have 4 plus 4, which is equal to 8. But our term is 11. Then you realize that that one does not work. Then you keep modifying until you come up with a formula that works for all the terms they've given you. So that's what we are doing. That's why people are having different answers. Then we check them and see if it applies for everything. Okay, now let's check this one. Yes, you can use multiplication, you can use division. This is multiplication, things like 4n. This is the same as 4 times n. 3n, this is the same as 3 times n. Then I think maybe we shall see some that have division, hopefully. So it can be anything really. Okay, so people are giving me 5n plus 1. Does anyone have a different answer from this? Okay, let's check if it is correct. You have your n is equal to 1, 2, 3, 1, 2, 3, 4, 5. So these people were stopping on the 5th term. So when your n is equal to 1, what do you get? When you put 1 in our formula that we decided on? 6, thank you. What about when you put 2?
You get
8.
11.
You get 11.
11?
Yeah.
Okay. Some people are disagreeing. Let's check and see. 5n plus 1. So when you put 2 in the place of n, you have 5 times 2 plus 1. So you have 10 plus 1, which is 11. Is it okay now? Okay. What about when you put 3?
You get 16.
16. Okay. What about when you put 4? I don't want people to
21.
be 21. Don't feel lazy about checking all the terms.
Then
When
you
you put
get
the 5th one, 5.
26.
26.
Okay, so once you realize that your formula is giving you all the terms the way they are here, then that is the formula that you take. So this will be our formula, 5n plus 1. Okay, so I hope people who have joined us today are following a bit. Let me put the next sequence, and as people think about it, I'll read.
Teacher, what about 12n divided by 2?
12n divided by 2, eh?
Yes.
12n out of 2, basically. Or you mean, do you mean this, or you mean 12 into n out of 2? Okay, it's the same reading. Okay, let's check and see. When your n is 1, you have 12 into 1 out of 2 by 2, 1 by 2, 6. So it's check for the first term.
Yes.
This class doesn't look very clear. Let me write here. Then let's check for n is equal to 2. When n is equal to 2, you have 12 times 2 out of 2, which is?
Which is 12. It's 12. It's an answer of 12.
And our second term is 11.
Is 11.
Yeah. So I hope I've answered your question. That's the beauty of math. Most of the things you do, you'll be able to prove them. So you can even leave your paper or wherever or your test when you know how many marks you have. So let me put D and E. Then I read your charts because the charts are many. 14, 19, 24. Now someone may wonder why are we struggling to find this formula. Later on we shall see. If time allows, we can see it in this lesson. If people are tired, we can see it in this lesson. You see, for us, we don't rush ourselves. We have time. The president keeps adding days. So we can just keep studying. I hope these numbers are clear. This is 4, 9, 14, 19, 24. This is 102, 202, 302, 402, 502. Okay, are the hands up for that for sequence? People are already giving answers. Let me first read chats. Let me first read. Oh, okay, let me see if I've missed out any questions. I think starting from here is where I stopped reading chats. Okay. I hope we slowed down a bit for Angela. Angela, are you following now?
Yes, teacher, I'm following. Thank you.
Okay, so Achen is saying, teacher, using number 1 as a reference, which one is the most preferred formula to use? The formula we have is the one that we have proved, because I think we had about 3 of them. We checked all of them, and this one was the only one that was giving us all the terms. That is how you define that's how you decide which one you're taking. You try for that, the first, the second, and if it applies up to the term they've stopped at, then that's the formula you take. And you'll find that most times it's one of them. Like it will never be Mbudeyatu and then you decide. No, it will always be one that gives you everything up to the last one. sorry about that. Okay. Can I use, yes, you can use a different letter instead of N. You can use M, you can use K, you can use Q, you can use A for Aliyah. Yes, you can use multiplication and division. The 2n+4 thing, I was trying to, because you use try and error, you try out and see. You first come up with ways you can, okay, you come up with many ways you can get from 1 to the first term. Then you use that to prove. So 2n+4 is one of the ways you can come from 1 to 6. But it didn't work. It didn't work for the second term. So we left it 2n. I think I explained this. Okay. Okay, I think now I've reached the answers for part D. People are giving answers for part D already. Do you have an answer for part D? You do not? Okay. Yes, Gabriela Nayevari.
Teacher, for part B.
Part D.
5a minus 1.
5n minus, before you use the A, 5n minus 1. So for part B, she has 5a minus 1. Okay. What about who? What about Alicia?
Teacher, for part E.
Hey,
100n plus 2.
100n plus 2. 100n plus 2. Okay, let me put part E here. 100n plus 2. Yes, Regina.
I have a question. My question is, when we are like, can we use this method when they ask us to find the next number in a sequence?
Yes, you can. You can first generate the formula. Okay, yes, I can use this as an example. Let's say they ask you to find the next one. Okay, usually it's very easy to tell a pattern from the sequence and just go the next number. But if you want, you can use the formula.
Yeah,
So you ask yourself, let me see, this is 1, 2, 3, 4, 5. So they've given you 5 terms and they want you to find the 6th term. So for the 6th term, what will your A be equal to? If that was your formula. People can't see it. Okay, for now, let me just answer your question. Yes, you can use
29.
the formula. Okay, 29. Okay. Now I'm saying, what will your A be equal to? What will you multiply 5 by before you subtract the 1?
6.
6. Okay, that means people can see it, but that's actually the next thing we are going to look at. That's the next thing we are going to look at. But just to answer her question, yes, you can use the formula to find the next term. You just need to know which term it is. Is it the 20th term? Is it the 7th term? Is it the 100th term? You need to know which term it is, so that you just replace it in the formula. If it is the 10th term, you put 10 where there is A. If it's the 11th term, you put 11 wherever there is A. Yes, Gabriela? Maybe you forgot your hand up after giving your answer. Okay. Have people checked? Have you checked that formula? Is it correct?
Yeah, it's correct.
Yes, it's correct.
You know, okay. What about for part E? Part E, I think it will have 100
100n plus 2.
plus 2. So is it working?
Yeah, it's correct.
Yes.
Okay, are there any questions about this?
This is exactly what I'm going to say now. Who is my black pen? I tell you, Abraham. No, I want mine. Abraham, can you?
Gabriela, your hand is up. I don't understand why your hand is up. Do you have a question?
No.
Okay, I'm going to put some numbers for you people to try. Then I'll help out my students. Then you can give me your answers. And then we can call it a day. You see me, I don't like over teaching. 1 hour is enough. And we've already used 1 hour. And some people have to drive to Cafe Javas to get their breakfast. And remember that breakfast offer ends at 11. So we have to consider such people. Where had we stopped? Let me use 1. So I'm going to use this time to answer people who still have questions about this. So you just you put it in the chat or you put up your hand. I think I should mark this instead of going through it. Let me see, I'll see after.
Singing as in. Are we posting?
Just wait, try to answer. We shall first go through the order. Then when you understand, you can write them down and answer them. Okay. So the part that we are remaining with is actually very simple once you understand this. So I'm going to really take my time here because once I do this, I'm literally done. People understand. So I want the formula. You can use N, you can use whichever. I'm already giving answers. Okay, you first wait. You do all of them up to 5. So if you finished up to 5, then you put up your hand. Okay, you know how to find the next number. Instead of asking the formula, I just find the next number. You know how to find it. You don't remember? No, it's not that I don't remember. There's a time in primary that I went over to learn Arabic. And I got that basics part. People have already finished up to 5. Let me give you some more time, like 3 minutes maybe. Okay, let's say 4. At 10 minutes past 10, I will come and take answers. Okay, I'm back. Let me see. People like Henry Van Nange, fine, and I'm going to hear a deep voice. Yes, Henry.
Okay, I did mine. It's 1 plus 1. 20. First one is 20 plus.
So you just
second one. My formula. First one is 20.
I can't hear you properly. Sorry, first mute Jemima. Okay.
My
you are
formula
saying
is 20.
2n minus
my first
1.
formula plus 1.
Okay, 2n plus
2n plus 1.
Then your second.
The next one is 6k minus 1.
6k minus 1. Okay, then the next one.
3k plus 1.
3k plus 1.
The next one is 3p minus 1. 3p minus 1.
3p minus 1.
Minus.
Then the last one.
And the last one, 4w plus 2. 4w plus 2.
4w plus 2. Wow.
4k plus 2.
What are the letters? Joka, you left out H, yet your name is Henry. Okay, thank you, Henry. I hope people can see those clearly. Yes, Miracle.
Sorry, I forgot my hand up.
You have issues. Then what about Jemima? Jemima puts up her hand and then she puts it down before I say her name. Okay, I'm seeing Rihanna has the same sequence as who? As Henry. Okay. Melissa, we are not finding next numbers. We are finding the formula. Let me see. Let me check.
Finding the formula. I already found the formula in the last lesson.
Oh, so you're moving forward. Okay, Purity has the same sequence also.
I found the formula already. I know how to find the formula.
Okay, it's good. It's good, you know.
This is my best and the other is my phone.
My student has given me her number 5.
Where is it? That flower was a video. She told me I saw it was and I do that thing. This is a face. Yes. What this is not a thing.
Sorry, Agatha. I hope it's a network issue. Okay, now I got the same. Okay, yeah, so most people have the same, but Elisha is asking, what if you say for number 4, n plus prime number? Let me see number 4. Number 4 is here. You say n plus prime numbers. This is correct. It is correct, but I wouldn't advise it because
I'm not understanding it.
Okay, let's first list prime numbers. Which ones are the prime numbers?
2,
2,
3,
5,
5,
7,
7,
11, 13.
And it doesn't even apply for the first one because if your n is 1,
yes, it doesn't. It gives you 4.
Okay. But I think I get what she was trying to do. Okay, sometimes you can get something like this and it is correct. But the reason why the reason why I wouldn't advise such is because now what if you have to set your sequence up to like the 100th term? If you're going to set your sequence up to the 100th term, that means you will have to list all prime numbers up to the 100th prime number, which will make your work hard. Elisha, do you get it? Like something like that may be correct. It may even be like n plus square numbers, but it will make your work hard in the long run because we are starting with this, but later we shall be finding sequences that even require you to find like the 1,000,000th term. So if you have such a formula, that means you would have to set all the prime numbers up to the 1,000,000th prime number, and then you add it to the n. Then another issue with such a formula, like how do you know which prime number you're adding? Because prime numbers we have 2, 3, 5. So how do you know that I'm saying n plus 2 or n plus 3 or n plus 5? Like when you group it like this, you leave it to the person. you leave a wide spectrum, like it's hard for someone to know which prime number are they adding. So I advise that you have specific formulas like this, so that people don't have to second guess your work. Okay? Yes, Jemima.
I never understood part B. Number 5.
D. Number 5. Okay.
Number 5.
But the others are okay. I hope the others are okay. I haven't marked these answers. I was just checking people who have same answers, then we mark. We can start with 4, with 5, then we check. So we've been using M, but you can change the letter and use W. So Henry used W. So Henry's formula is 4W plus 2. So to get the first term where there is W, you put 1. So you would have 4 times 1 plus 2, which is equal to 4 plus 2, which is equal to 6. So this is my first term. To get the second term, your W is equal to 2. 4 times 2 plus 2 is equal to 8 plus 2, which is 10. So far the formula is working. You go to the next one. 4 times 3 plus 2, which is equal to 12 plus 2, which is 14. It is working for the third term also. We go to the fourth. 4 times, Jemima, I hope you're following. 4 times 4 is 16. Sorry.
Yes.
Plus 2 is equal to 18. So it applies for the 18. Then we check the last one. 4 times 5 plus 2 is equal to 20 plus 2, which is 22. So his formula is actually correct because it has corresponded to the whole sequence. I hope I've answered your question. I hope so. Well, I hope I've helped you understand. Basically, what he was trying was to explore his letters. He only used N1, then he used K here, then he did W, but we use them the same way. How do you know a sequence requires either subtraction and addition? It's try and error, but a hint is if a sequence is increasing, then there are only 2 operations that can, actually there is only one sure operation that can increase something, and that is addition. If a sequence is decreasing, then subtraction. Then for things like how do you know whether I'm adding 1 or subtracting 1, it's try and error. It's try and error. You first test 6k plus 1, you see, does it work? If it doesn't work, you try the minus. If it also doesn't work, you go to 2. 6k plus 2. If plus 2 doesn't work, you say minus 2. It's try and error. Why? Because we do not know where this person got his sequence. We do not know. And we are learning this because sometimes you get the information from around you and you have a sequence like this, but you want to be able to come up with a formula that will help you predict what will happen after years or what will happen after several trials. So that's why we are supposed to be able to look at a sequence and generate something. I even wanted to show you people a video today, but our time is even up. We shall see that video next time. N plus odd numbers. Hirat, I explained this. I hope you got it. Like such a thing may apply, but now how do you know which odd number to add? Because for you add 1, me I'll add 3, and then someone else will add 5. So for you, how are you going to limit all the people? Let's say you're carrying out research, you have your people you're supervising, and you're telling them our formula is N plus odd numbers. So this one uses 3, this one uses 1. How are you going to tell them no, we are using 3? It's hard, it makes your work hard. And remember, once you generate this formula, you're going to spread it out and give it out. Henry, you're asking questions that are not related to this topic. But also, I would have answered, but this is out of your scope. You'll be able to do such a number after you learn quadratic what? Either quadratic expressions or equations. That's when you'll be able to do that one, Henry. the one you've asked in the chat.
Okay.
Okay, my student is saying we end at 10:30, but it's not yet 10:30. You cannot concentrate for 1.5 hours, you people. Even 1 hour is a lot.
Teacher,
As long
I
as
can.
you
Okay,
can.
I can. Yes.
Maybe over on a watch, I even don't know. Okay, but do we
I've
agree
been
with
concentrating all this time.
Are there any questions to answer? No? We have 6 minutes. Okay. Let me play that video, then I'll talk about it next lesson. In the next lesson, I'll talk about it. But for now, let me play it, but I won't talk about it. Yes, some people are tired. I know even by the end of 1 hour, you're tired. This may soon also. First, she had breakfast. Okay, let's stop here. We shall watch the
breakfast.
Shall watch the video next time. Okay, Miracle even says we shall forget. Okay, we shall watch it next time and then I talk about it. Is that okay?
Yes, teacher.
Yes, teacher.
Okay, bye.
Bye.
Bye, teacher. Thank you for teaching.
Thank you, teacher, for the
Okay.
lesson.
Bye, teacher. Thank
Okay.
you for teaching.
Bye.
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 Bye, teacher. Thank you for teaching.
You're welcome.